The APP approach builds a rounded picture of students over time based on activities and conversations. Let's see what Tom Pull, Head of Maths, gleans from 2 lessons investigating angles.
Just have a look at this video, and what I want you to think about is what maths can you see in the video. We're doing a mini project which is part of our APP process and is essentially an in-house kind of rich task that we've developed with the idea of trying to get a better idea of where students are. A rich task is the sort of activity where there's a number of paths that the students can take and it can lead them to different answers in the end. The idea is that the curriculum comes first and the assessment comes out of that curriculum, so that we're not just sticking assessment on at the end. I'm going to tell you one little fact about pool tables. However the pool ball hits the table side, okay, so hits the cushion there, it will bounce off at exactly the same angle. We're just going to look at how the ball behaves after 2 bounces off the cushions. The important thing is up to you what you're going to do. If you can see some maths that you know about, that you think's really difficult maths that you want to show off about, then go down that way and experiment with that.
All the angles that we're using here add up to 90 degrees.
Okay, can you use any angle facts to explain why that is? A lot of them, what they're doing at the moment is just noticing that the 2 angles add up to 90. What I want them then to do is reflect that back into the angle fact and see that that relates to the fact there's a 90 degrees in the corner. Can you add anything to that diagram that might help you then with angles if you know you're working with a square?
Triangles.
Huh?
Triangles.
Triangles. Okay, so we're talking squares and triangles now. We've got a square there, and you can see some triangles. That's the direction you should be heading in terms of trying to explain what's going on. It's an essential part of APP because of the fact that if they can explain to me that it's 180 degrees in a triangle, they're showing me a level 4 skill there, essentially. And verbally is enough for me. They've said it to me, so I know they've reached that point at that point.
Whatever angle that is there, then it's going to be the angle that is bouncing off at. So AA.
The bouncing around that the students kind of do in the first lesson is all about the conflict they're having. There's a conflict behind kind of them coming up with ideas and not being sure if they're correct. And so there's a confidence building kind of element there. The bouncing around is experimenting, seeing what works, what doesn't, making hypotheses about what they think is going to happen, and then trying practically to see. What if we didn't know what that angle was? What if that angle was N?
You'd work it out.
If a student gets kind of stuck and pinned down by a concept, I'm quite happy to let them battle with that concept for the hour, and maybe they don't get miles into the mini project, but because we're doing this over and over again throughout the year, we're going to get a picture in other places. OK, Adam, tell us what you're doing then.
10 plus 80 equals 90, and
right.
40 plus 50 equals 90.
Right.
And I've found out the nth term, so the nth term would be n plus 90 minus n. That would equal 90.
Fantastic. Now, what I'm really interested in here, OK, is that you've been going around and you've been changing the angles, which is absolutely fantastic. But now you're starting to think about, what if I don't put a particular number down, but instead I put down n? Could you try drawing out your diagram, but instead of putting numbers in that diagram, could you try putting those angles that you've started there? Because you've certainly started it, but it'd be nice to see it in a diagram, and then maybe I'll be able to see what other kind of patterns is coming out from that. That's fantastic. Heading into algebra, absolutely brilliant is where I want you to head. I'm holding back very much, so I'm just trying to push them in the right direction when I can. But at the same time, if I can, what I'm trying to do is get the students to explain to each other what's going on. So if they ask me a question, what I'll often do is defer that question to somebody else on the table. OK, good. So you've noticed that there's a pattern going on here where you've got this alternate going on. And you've also noticed that n plus a equals 90.
Sir, I think, this is Adam's method.
Right.
I think it's like the same as mine because you've got n plus here and 90 minus n is another number. And if you could just call that a.
Oh, this is really interesting because what you're doing there, right, and that's absolutely fantastic, OK, is you're doing what's called algebraic substitution. OK, so you've noticed that this actually looks the same as this. Yeah, and look, you've taken that 90 minus n, you've said it's, that's great stuff. That's really high level algebra that you're doing there. I'm really, really impressed. I expected them to use some algebra, But what I didn't expect was for them to start coming up with different formulas and then comparing them and then being able to see that they were actually the same algebra after all, which was great, because there was an element of an algebraic manipulation in there, and part of something that I've not taught them yet, that they started to come to grips with themselves.
I don't really understand how it's n take away, and 90 take away n.
It's because the n you've got, if you take it away from 90, would make a number add n equals 90.
Can you relate it back to her diagram here? Can you show what's going on with the diagram?
I think it's definitely better than doing tests, because you get to interact with other people around you, and you get to, like, because Mr. Poll actually comes up and, like, gives you kind of clues, and it really, like, helps you a lot.
It helps me understand my assessment levels, because it knows how to improve on which areas of teaching you need to improve on within these challenges.
It makes me a better mathematician, because you have to really think about, like, why, and he helps you, but he doesn't give away the answer, so you've got to always do a bit yourself.
What I'm trying to do here is reflect on what the conversations that I've had with certain students in the lesson. I'm then going to have those ideas about what's been said to me, and what I want to do is I want to relate it back to the level descriptors that we've got, and when I'm in the next lesson, use that as a way of, perhaps when I'm talking to a student, see if perhaps I can draw out how they would be moving up onto the next level there. But I've then got an idea of where that next level is, according to what I've got down here. Good afternoon. The next step that we've taken is to introduce homeworks. And in those homeworks, we're kind of looking at much more kind of show me homework, where the students are once again sent off with perhaps a slightly tighter task, but nonetheless it's got some openness in it.
What we're going to do today is have a look at the homework that you've been doing over the last week. And remember that the purpose of that was for you to be able to show what you know about sequences. And in fact, you're going to look at each other's homework and see what you can find out from what other people in the classroom have done. And you're going to give it some marks. You're going to mark it out of 30. This particular task was based on the work that they'd done for about 2 weeks on sequences. It wasn't a difficult thing to fit the homework around the APP idea, and in fact it fell very naturally. This very brief period of peer assessment, it takes about 15 minutes at the start of the lesson at most, reveals an awful lot, because whilst you're circulating as the teacher, you're hearing 30 different interpretations, and hopefully they'll be thinking about their own practice and how they can be developing themselves as mathematicians.
Very good explaining turn to term and position to term rules. Very good.
We learnt T notation in the class, and the whole idea was basically so we could understand it more and be more confident in it. And it's a good way of solving out different problems and different sequences.
Has Esther got the perimeter and area right?
Yes, so she's got everything written down on each of her drawings, and she's also got the term-to-terms right, and she's explained the term-to-terms in each area that you wanted to know about the term-to-term role and the position-to-term role as well.
She's used the T notation quite well as well.
Yeah, I think the maths in it is quite good. And she's tested out some different possibilities, not just what we were asked to do. So I think that's good.
Instead of somebody just telling you everything, it's just good to know that you can work it out by yourself and everything.
He doesn't like to make it boring for us, he likes to make it so we enjoy it as well as learn something.
The only thing that we're finding difficult at the moment with building APP into our scheme of work is to find a way to be standard across the department and moderating the way that we're assessing students. If the other member of staff hasn't seen how the student has progressed in the lesson, then they can get a very different impression of that child just from their written work. So it's nice to be able to see and to level the work together and to see how the sort of verbal evidence combines with the written evidence to give that your impression as their teacher.
She's used some shape and space in here in terms of the pyramid and stuff, but that's not getting up any higher. It's just showing that she's confident kind of around everything. That's representing that you're adding an extra 2 on each time, and that seems to be quite thoroughly understood by her there. So overall then, we're kind of saying it's around a kind of a lower level 6. Yeah. In today's lesson, what you're going to be doing is you're going to be writing an introduction or the first chapter for Pool Tricks for Dummies. You need to show me what maths you can find in this situation. The more you can show me and the more explanation you can give me, the more I understand about how well you're doing this.
You got AA, NN. So it's changing sort of. So it's not actually NA. And I'm not sure how I'd explain that on the sheet.
One of the really important things is that you're having a go at explaining it for yourself. Have a go at it, and then perhaps show it to Lucy. Yeah? Get her to have a read through, and if she doesn't understand, she can tell you why she doesn't understand. You can have another go at doing it.
I'm not sure why that's an A there, because it should be an N. Look at this, it's N-A-A-N-N-A, and that's got an N-A-A-A, so I'm not sure why that is.
Isn't that an A because it's an alternative angle to that A?
Yeah.
It's a valuable way of collecting the APP evidence because it's about being able to observe, as much as you ever could, the learning process going on. So it's not just about what skills they've got, but how they acquire skills. What is this student good at doing and getting better at? What I want us to do is I want us now to have a look at what everybody else has done in the room. I really want you to really try and get into the heads of the person that was writing it down and try and understand what they were meaning.
I didn't think of that for 2A and algebra. It's quite good, isn't it?
When his son explains the nth term, he explains it really complicated, where you can't understand.
If you keeps going, it'll be quite good. Yeah.
The peer assessment is essential. They're kind of seeing those other maths projects and therefore perhaps get an idea of this is a good maths explanation and this isn't a good maths explanation. And then that gives us a chance then to perhaps have a discussion about what we see as a progression and what they see as a progression.
And it gives you things to do, it says you could use 40 and 50.
Most teachers have found some difficulty in moving from the summative to formative. I think we are all very much still learning in it. But when you're doing an algebra lesson and you're just doing some rearranging, you're just looking at one skill. But when you're doing kind of an open project like this one, there's literacy skills in there, there's all the elements of maths, there's organisational skills. And I think for teachers to come to terms with the fact that because there's a lot more skills involved, you're going to see the learning in a very different way and you have to be more patient with the way it comes up. I think, yeah, that's quite a hard thing to come to terms with because we don't want to feel that students haven't made a lot of progress in the lesson. And often the progress you're looking for is not the same as filling out 20 questions. In an ideal world, I'd be looking for a system where even in Key Stage 4 we were encouraged to use a formative kind of working model. And what really we need to see is kind of an opening up of that and a change in the exam so that students can work in a different way. Hopefully what you've seen is some really good examples of bits of maths you didn't think about. When designing the APP framework, what's really, really important is that you don't start just by sticking on assessment at the end process. What we're looking at is starting with the curriculum. What's good for the curriculum? What are the good activities, the good learning activities that we want to see the students doing? And then fitting the assessment into that process.